Good afternoon, Packaging 450. Welcome to Lecture 13. Wow, I can't believe we've made it to Lecture 13 already. We're starting Chapter 5 today. I know that this week you turned in your Chapter 4 homework yesterday on Monday, and I am going to I owe you some homework responses. I will be getting that to you all within the next day or so. So look for that for Chapter 3 and Chapter 4, actually. We've covered a lot so far, so much to learn, so much to do in automotive packaging, never a dull moment. It's fast and furious, no pun intended for the car movie. So let's get started. Today we're going to talk about return on investment, and that is basically how you calculate containers when you buy your fleet, you determine your fleet size, and you are trying to justify that there is a cost benefit to buying packaging for a program and what type of packaging. So let's get started. I am going to share my screen, and because I'm a packaging nerd, I have to start with some packaging humor. So you all may not laugh now, but one day you will.
The customer journey builder is Chuck.
Okay, so I guess you can probably figure out who the packaging engineer is in that family. So I just thought that was really funny, and I hope you guys got a little humor out of that. Okay, so back to Chapter 5, return on investment. So again, we're talking about making a business case, because as I mentioned before, if you purchase something like this, a returnable pack, you are buying an asset for the company. So something like this would be the same as buying a piece of equipment for the line, so it's goes into, if you all have taken any accounting classes yet, or when you take them, you keep this in mind, because this is something that it's categorized a specific way in the accounting books, and then it's handled a certain way. So when they buy the containers, it's considered an asset, they own it, and they have to keep track of it. So when you do that, the purchase amounts of these are pretty high. So again, an example would be buying packaging I worked for a seating company that made automotive seats. For any vehicle that we were building, even a small one, there were normally about 300 parts for any vehicle seat. Or the set of all the seats, say about 300 parts. And we would easily spend somewhere between, $300,000 to $700,000 for one vehicle program. And this is for a tier 1 that's shipping the finished seats to an OEM. So that gives you some sort of frame of reference. I know we talked about numbers for the OEM, and they're spending millions of dollars. So that's just for one part coming in from a supplier. And at those numbers, companies aren't just going to sign off on it. You can't just put it on your company credit card and you have your manager sign off on it. This requires signatures from like your manager, your manager's manager, the director, senior director, it could go all the way up to the VP. And if it's a small enough company, it might actually go to the president, or if the president of that company or division has a lot of financial control, they will want to sign off on it. So you think it's just a container, but something like this, purchasing 1,000 of these, is something that can get visibility up to the VP level easily, if not president level of a company. So that's where the business case comes in. Most companies will have a standard business case that they use, but we're going to talk about the basic elements, and then over the next few days, I have some other examples that I can show you so you can see what they look like. But today we're just kind of going to go through this process, what it looks like. And if you have any questions, as always, you can email me. You can, I think you should have my number. You can text me if you need to. You can send messages on D2L, and or you can come to office hours, or you can jump in at any time on these lectures from 2 to 4. I also will say that next week I'm going to be traveling, so I'll probably be filming. I think I'm going to end up pre-filming all 3 next week versus live. So if I can do anything live, I will, but I just want to give you all a heads up. Okay, back to chapter 5. So again, I mentioned the business case, and this is usually done when a company either has a new program, they've never bought packaging at all, and they decide they want to look at returnable packaging, or maybe they have a part that they've been shipping in expendable packaging, and they want to do cost justification to ship them in returnables. So you have to do a cash flow analysis, which will calculate that ROI, or the return on investment. And that's, like I said, this is something they do in automotive when you're looking at returnable packaging. And then when you do your return on investment calculations and you do your business case, this gets presented to management, and then they will look to see, which scenario makes the most sense. So many times, because returnables have been used in automotive for decades, and I'm going to post that video if it's not already on, so you all can look at that, because I've decided I'm going to do some extra credit. So extra credit is going to have to do with this video, and the guy's name is Stephen Beeler, and he was in automotive engineering when returnables were instituted in the 80s. So I did an interview with him. That is his name. You will see his video. I'll post it, and anybody that wants extra credit, you can watch the video, and I'll give you some instructions on what I'm looking for. All right. So again, when they look at these business cases at the leadership level, the managers will determine which ones make the most sense. Like I said, in the past, the justification was comparing one to the other, and they might have multiple ones to choose from. But because automotive has been doing this for so long, a lot of assumptions are already made. So the assumption is that the business cases that are being presented are the ones that make the most sense. They also may have a budget in mind of what they want to spend. So the main thing that they're looking at is, are these projects within the budget that's planned for packaging and for this launch, which goes back to what I keep saying: make sure you have a good relationship with your program management team, with your finance team, with your engineering team for the product. Make sure you have good relationships, and with purchasing, because these are people that will be part of that decision. And you want to make sure that they understand the benefits to returnable packaging if that's what you deem to be the best. So again, I'll show you some examples of, looking at returnable versus expendable and that kind of thing, so you can see it as we go through this week's chapter. So this is the calculation that you're looking at. You've got the return on investment is taking the cash that comes in, subtracting the cash that goes out, and then you're going to divide that by the cash that's going out. And that's going to give you, like, also you're going to take the profit over the cost. So all those are ways to determine, or numbers that are used to determine your return on investment when you're trying to justify a purchase for returnable packaging. Okay, so here's an example. Go with a simple example. And let's say, you're trying to make some new item. You've got your materials. That's a cost of $10. Okay, let's see if I can get my annotation to work today. Okay, so you've got your $10 for materials. Gets on my nerves. Okay, your $10 for materials and labor. And then you sell the product for $15. So your cash in would be 15. Your cash out is 10 and 10. So you're gonna have, I do not know why this pen does not want to work for me. That's why. It's to do text. Okay, so here you're gonna have your cash in, which is 15, minus your cash out, which is 10, which is what you spend on your labor and materials. That's going to equal 5. And then you can take that 5 and then divide it by your cash out, which is 10. And you're going to get down here 0.5. Okay, which is also equal to 50%. So how you get that is you can say, you can just say 5 over 10 until the equals a half, or 0.5 is a half, or 50%. Those are different ways to say that. So let's get out of this thing. Okay. So when you look at these numbers, so for here, your ROI is 50%, which means your return on investment is 50%. But you can have different return on investments, and you want to try to get your return on investment as high as possible. So for example, you have a baseline. If you say your ROI is 0, that means that you broke even. So that would be equal to, let's say that you spent $10 on materials, but you only made $10. Most companies will, and if it comes out negative, that means you're losing money. So that would be, let's say that you spent $10, but you only made $5. Then you made less than what you spent to make that product. So every company will have an ROI that they deem to be what they want. So some will say they need a 50% return on investment. Some will say they need a 30% return on investment. Some will say they need 100% return on investment. It really depends on the company, their accounting processes, and really very important to this is how well the company is doing. So an automotive company during a downturn, they will increase their return on investment, and the requirement is much higher. So it just depends on what's going on, the state of the business, their margins, how much money they tend to make in general, what the profit margins are, and all those sorts of things. The next concept is depreciation. And that is something that if you have had accounting already, you've heard about it. If you haven't had accounting yet, then keep this in mind. Hopefully these will help you with accounting to understand it. But the part that they buy to hold the product, its packaging, I should say, once they buy it and they own it as a capital expense, they have to depreciate it. So this is something that is required by tax law, because they're saying that if you have this for so many years, you're basically breaking it up into, the amount of value it's kind of like a car. When you buy a car, and when you first buy the car, let's say you pay $20,000 for the car. And then they say when you drive off the lot, it depreciates 20%, meaning it loses 20% of its value. And then if you go to Kelley Blue Book and look up your car and see what the value is, you'll see, well, I paid $20,000 for this car, but now it's worth $8,000. So that tells you that your car is depreciated by $12,000. It shows you like how much value has left your product. Again, and this is something that companies and can put on their taxes. So it will, so they'll, what they'll say is just like your car. You take your car, you get miles on it, it gets dings and dents, it doesn't drive as well. So when you go to sell it, it's not worth as much. And they have a calculation from a tax standpoint that's the same thing for these. So they assume that when you first buy it, it's got its full value, but after a certain period, that value is no longer, it's not the full value. So over time, I try to remember what it is. I've heard multiple things as far as the timing, and there are guidelines for tax purposes from the IRS, but most companies, the companies will know this. So this is where your accounting and your finance team come into play, because they will know what that is and they'll already have calculations on how many years it's broken out. So it's not necessarily anything you have to worry about, but it's something for you to be aware of and understand. Because when we talked about, like, at the end of a program, when this vehicle is no longer being made and you still have some containers left over, what do you do with those? Because let's say they've depreciated them over 5 years. So at the end of 5 years, they technically is worth zero, but you still have this physical asset and you can still use it. So it does have some value, but from a tax standpoint, they've already said it's not worth anything. So technically they could just throw it away. And they basically consider, we've used it up, we've disposed of it, but many times they still keep it. So that can be very, from a finance standpoint, they'll make decisions on how they handle those things, but it just really depends on each company. They follow, like I said, they follow IRS guidelines, but it really depends. So okay, so in the auto industry, we talked about the life expectancy over, time. So you have some equipment that they buy. I'm gonna say maybe some electronic equipment that they know is only gonna last for a year. So it doesn't have they don't have to depreciate it on their books from an accounting standpoint. But you get other equipment like a computer that is going to last 2 to 4 years. So when a company issues you a computer, the value of it is higher when you first get it. But then let's say you start using it, the memory gets full, maybe you drop it a couple times when you're walking in a plant, or there's some software, maybe you don't have the memory, so now the software won't load, or you put the software on, it starts getting glitchy. So after about 4 years, they assume from 2 to 4 years the company's going to get you a new computer, because your current computer is not worth anything. So they spread that value out over time to say full value next year. They subtract a portion of it, so it's worth less, but they can take that off the accounting books to say, balance out their accounting books. And again, I mentioned it's set by the IRS. You get plant equipment like, a production line or maybe a conveyor or something like that. And that tends to depreciate over a longer period of time, like 5 to 10 years. And then you can get things even like a building. So buildings, even though this building, can be in use for longer than 20 years, from an IRS standpoint, they will depreciate that building value over 20 years. So you go at year one, it's worth this amount, and then it will, over time, the value will come down. So even if you're in a spot where you buy real estate and the value of that real estate goes up, from an accounting standpoint, that's not what they're looking at. What they're looking at is how much you spent on it and how much of that spent value have you used up. So again, you spend $100 on this, it's going to last for so many years, but over the purchase price that you paid for it, they're going to chunk that out from an accounting standpoint, so that by the end of the 5 years, they can say, yep, we've used it up. And they can assign that value, that what they paid for it, over the time period and chunk it out versus it's just being one big chunk, because then it can cause issues and look like it's a loss, or it can affect their, by spreading it out, it has less of an impact on like the bottom line of the company, which can affect their annual report, which if they're publicly traded company, it can affect their stock price. And who wants their stock price of a company to be affected because they just offloaded the value of $5 million worth of plastic containers that they are still using. So there is just, it's really an accounting issue. So keep that in mind when you, if you take your accounting class already, or when you get ready to take your accounting class, if you haven't. So this here, it says that most returnable containers have a useful life of greater than 5 years. Okay, so they can last 10 to 15 years. And I've seen some, because I've even seen some that were Chrysler totes, for example. And they had the Chrysler, I don't know if you remember, Chrysler used to have like the pentagram, which was like a pentagon with a star in the middle. And I've seen totes that have that logo on them. Now, Chrysler has not used that logo for maybe 20 years. So easily 20 years. I know that in the 70s, they were using that logo. So some of those totes can be really old, especially if maybe they're shipping light parts that are clean, they're not oily, and they're maybe just going across the street and they get light handling. Things like that can last for a really long time. So, and they don't get lost. So here, you know, the 5-year number is used though most of the time when you're doing the calculations for your return on investment, because that's saying worst case, this, if we have to get rid of these in 5 years, we lose a fleet or get broken, it's a really rough environment. That is a very conservative number, because you're saying you're using it over a short time, and that cost gets spread out over a shorter period. So the chunks are bigger. So that's going to give them a worst case scenario, versus if you take the same tote and you spread it out over 10 years, that amount is even less. And you'll see with these, you know, calculations that how you spread out that depreciation of the packaging can make a big difference in your ROI. So here it says again, if it's a conservative, because if you show that the investment is a good idea, if for 5 years of use, then, and you spread that out over, you know, 10 or 15 years, it's going to be even better. And you'd rather start off conservative and have the bigger chunks and show that's the worst case scenario, and then come out, you know, it can only get better. So you don't have to, it takes away the concern that we could lose money on this. So, you know, when I was giving the examples about losses, or for, you know, when you do your ROI for negative ROIs or breaking even, by doing a 5 years, it's more aggressive, and you can see where you break even and when you make money and when you have a loss. Okay. I'm gonna do real quick. Let's see if I can do this. I'm gonna get fancy here. See if I can erase this, because this is, oh, it worked. Okay. All right. I didn't want to keep looking at that. Okay, people. All right, I'm back. Okay, so interest and taxes. So, so when this was written, obviously the cost of borrowing money and interest rates are still relatively low. So they're still low. But in the past, interest rates were double digits, even, you know, really high. So the cost to spend, to the money, the amount that you spend on interest payments to borrow money was much more significant. So one of the things that they do is discounting when, you know, when the interest rates are higher. And when they discount, what it does is it'll take that return on investment and it will help to reduce the amount of interest paid. So it looks better on the books and they're spending less money over time. So we'll give examples later this is just something to know, but it's not going to be something that we include in examples. Okay, so one of the things that's important is, having good information. So when I talked about earlier, again, having a good relationship with your team and keeping track of everything that you purchase, what the cost was, when you bought them, all those sorts of things, and then keeping track, with inventories. And when inventories are done of products, as a packaging engineer, I would highly recommend that if they're only counting the parts, that it would be a good thing if you were able to get a count of the containers as well, because you want to see how many you have. So let's say you buy 1,000 of these, they're counting the parts in these. And if you can get an inventory of packaging done at the same time, because what happens is they have to do it when the plant shut down because they don't want to do it while everything's moving. So, this tote comes with the parts and someone counts it over here, then the fork truck picks it up, takes it to another station. And then at that station, you've got people counting. So they count that container and those parts again. So now it's double counted. So you want to make sure everything is steady. And if you can get containers counted at the same time they count parts, that's a really good time to gather data to say, I started off with 1,000. When we did our inventory a year later, we had 900. That's a piece of data that we lost 100. And then the next year you do a count and you should have 900. And next year you have 700. Well, that's flag. There's a flag that you're losing containers. Or maybe first year you have 1,000, you look and you say, okay, the next year we have 900. And then you say, okay, we need to buy more. Maybe they buy 100 more. Maybe they buy 200 more, expecting to lose 100. And then by the end of the next year, when they do inventory, they should be even and have 1,000. I'm just making up an example. But when they do inventory, they find out that they only have 500. That's a red flag that something is, why are these containers getting lost or stolen or broken or whatever it is? And it tells you too, like how many you would need to replace over time. And when you're also doing your fleet calculations, you're going to add in that loss number. So, a lot of people are using standards, 10% or something like that. But if you know that your loss rate is higher or lower because you've been keeping track, that is very valuable as far as data collection is concerned. Because we get to the end of the program, and if you've been keeping track of your containers, whether you're doing inventory or some container tracking technology somehow, it helps to know for the next program how many you might need to buy, what your buffer might be. Also, if you have extra containers left over, you'll know, and maybe you can allocate, okay, we use these things for everything. We can use this again for the next program. So we start off at 900, we replenish during the program a little bit to keep it even. And at the end of the program, we find that we have 500 good ones. So that's maybe 500 less they have to buy. A lot of the return on investment calculations, though, don't always take that into account. But again, that's where that data collection comes in. So this is just talking about how do you build the cash flow analysis. You want to make it as believable as possible. You want to use what's really happening versus what you want to happen. Because if you want to have 900 containers, but you learn that you really need 1,200, you want to go with that. Okay, so as we're going through this, for this chapter, the assumption is that this company, whatever companies that we're talking about, they're using expendable packaging and they want to justify switching over to returnable packaging. So when you hear them talk about current state, is what they're currently doing. They're using expendable packaging. And then what they're proposing, or for their future state, to what they're going to use going forward, and what they are doing their justification on, is for returnables. And I mentioned again, data collection is really important. You want to keep as much information as possible. You want to explain what's going on. You want anyone to be able to read this and understand it, because one of probably the most challenging things is if you have a return on investment calculation and you're doing your business case and you're missing some information, you give this to leadership, or it gets to leadership, and they just want something very quick. They can easily read it and make a quick decision. And they're like, I need more information. I have questions. And that could delay the approval. So, we know the lead times on these containers can be very long. On some of these plastic returnable containers can be very long. So the last thing you would want to do is have a delay because one of the people signing off needs more information. And then by the time you get them the information, maybe they're on a business trip. And many times these approvals go through a certain, like, person number one, then it goes to person number two, person number three. They will have a specific sign-off process, and it goes in a certain order. So if that one person has questions or they're out of town, it gets delayed, no one else down the approval chain can sign it until that person signs it. So you want to make sure that your return on investment calculations and your business case is really tight, and that if you have any questions, or you think there might be questions you anticipate, you want to have that information in the back of your study. So if they can reference it, they might have a question and they see, oh, there's supplemental data, they can go back there and look and say, oh, okay, here's my answer to my question. And that would, keep it from getting delayed. Okay, so you can see here lots of costs are involved. So, you have like cost for labor, cost for the process in general, transportation, inbound for the parts that are coming in, outbound for the parts that are, going to the next step. So if you're a tier, you're shipping to the OEM. If you're an OEM, you're shipping to dealerships. If you're a tier 2, you're shipping to a tier 1. So whatever your beginning and your end are, those are cost examples of the cost of parts. You may think that the cost of the part is irrelevant, but it actually can be very relevant, because let's say you have a part that's a penny and you have a pack that's $30 and you have 4 parts in it. It doesn't make sense to spend $30 on a pack when you're only putting 4 parts in. Those parts are really cheap. So even if you had, let's say, even if these parts were $1 each, okay, so we're gonna round it up. So let's say you have a pack with 5 parts, each part costs $1, but you spend $30 on your packaging and dunnage. So when you take, or you're paying like $6 for every $5. You're paying $6 for the bin and you're paying $5 for the part. You're paying more for the packaging than you are for the part. And when I say the $6, it's like you send $30 for the pack and the dunnage, and then you have 5 parts. So you take the $30 divided by 5 to have, $30 per 5 parts. And that's how you know that when you calculate that out, the 30 divided by 5, you're going to get $6 per part for the pack. So, those are things that you want to keep in mind. I gave you this example. It was, it's a round number. It's just so you can see for illustration purposes what that means. You want to keep track of, what's going on in your, with your processes. Maybe you're looking at a bin, no dunnage, but you find out during the course of this that maybe there's some new technology. Maybe there's now some, sleeve pack or some pack that's a component, and this breaks down, you can ship it flat. You get, better utilization when you're shipping it for your return shipments. That saves money because you're using fewer trucks. So those are some of the things that you need to look for. So what you're basically doing is showing, how this pack would benefit your process from a cost standpoint. But that includes like the cost of, like I said, processing, material handling, transportation, all these things come into play. You need to keep in mind. All right, so once you have done your business case, you've submitted it, and leadership has looked at it and has been approved, now it's time to implement. So what happens is, so this is giving an example of the OEM. So the OEM is the owner of the returnable container, but we mentioned before that the supplier may buy them and then the OEM will pay them back over time. So that's a whole process that needs to happen. There's paperwork for it. Purchasing will get involved, program management will get involved, and they'll make sure that that money is allocated to the right bucket. Because earlier, again, I keep going back to, working with your program team. So this goes back to like the phase for like phase 0 or 1, like where you're concepting and doing preliminary budget guesses. You're estimating what your budget will be. From a standpoint, a packaging, you've kind of already estimated, I'm going to spend $500,000 on packaging for this program, or $1 million, or whatever they might be. You've already made a guesstimate. Now you're at the point when you do this, you're getting even closer to how much it's really going to cost. And that's when, OEM will authorize it. Program management team and the purchasing team, they're going to make sure that any purchase orders get placed so that the packaging can be purchased and the packaging will be purchased on time. But as the packaging engineer, you will be a part of that process to make sure that it's happening. The program management, where it says program management will be responsible for implementing the plan, what that means is they'll be following up. They're going to have a chart with dates, and their job is to make sure you don't have any roadblocks. So if you have any issues, you go to the program management team and say, hey, purchasing has signed off on this yet, or finding out that the lead time is longer, whatever that might be. And then the program management team would get all the people together that would be needed. And, you would work to resolve that problem, that whatever that issue might be. Another thing is, when those containers come in, confirming that the containers come in. I worked for a company once where the supplier said that they shipped in the returnables, and it was enough returnables where it would have been obvious in the plant that they came in. They would have had to probably move some old stuff to make room for it, and I never saw it. And they wanted me to sign off on the packaging and say it was there. And I said, I have no proof that this was delivered. I can't even find one of these. So things like that. So they were trying to get paid for the packaging and they never shipped it. So, then they would turn around. What they plan to do is turn around and say, oh, they're short, they don't have enough. And then they would buy even more. So they were planning on selling the packaging twice that they never shipped to the plant. So that's why it's really important to know what the suppliers are doing, know what the plant needs. We did the example of a couple of different examples of like how much space does a truck take up? How much space does 400 trucks worth of material takes up? How much of that space needs to be available in the plant? Also, buying racks and metering them out, bringing in a few at a time, understanding how many you can bring in at a time based on their volume needs and how much floor space they have available for storage. Those are things that you need to keep in mind. And that's, part of that delivery schedule that we talked about that was in your homework. And then transitioning from the expendable packaging to the returnable packaging. That can be interesting because some plants, they'll just take whatever comes in first. So I'm going to talk about warehouse concepts a little bit. We've got the like FIFO and LIFO, which would be FIFO is first in, first out. LIFO would be last in, first out. And what that means is when a truck comes in to the plant, the truck will come in, they will take the product off the truck, and then they might put it in storage, or they might take it straight to the line. Generally, when you start talking about like FIFO, it generally means you probably can assume that there's going to be some amount of material that is stored for a certain period of time. So FIFO would mean the material handlers, the fork truck people, they would have to be careful, because let's say this is the first one in, this is the last one in. The fork truck driver brings the first one sitting in the storage space. The warehouse driver brings in the last in, puts it on top. But if this plant is using practices of FIFO, which would be first in, first out, this one needs to be accessible, which means a fork truck driver would have to come, take this, move it, sit it down, and then come get this and move it. More than likely, the fork truck driver is going to pick this one up, have it on their fork tines, and take it right to the line. Meanwhile, if you have a product that could go bad or rust or anything for any reason, and you want to make sure that you keep the inventory as new, as fresh as possible, then you want the first things to come in to be the first things that you use. So more than likely, then you would see it where maybe it's this way. They put it here, and then they would come pull from this side and take the first one. The first one in the line is, the first one out. So they pull that one, and then the next time when they come and use this one. So there are just a lot of methods for that, but I just want to mention that a little bit because that ties into the whole process of like metering your parts and understanding what's what. You also don't want parts to sit in forever in the older packages of product to sit, because maybe the engineers make a design change. So again, first in, last in, they made a design change on this. This is obsolete. So now if they pull this out and they're going first in, first out, they need to know this is obsolete. So there are a lot of ways to tell that. They might have warehouse management systems that will tell them, where things are, how old it is, and those sorts of things, and maybe even what the lot is, so they can trace old lots and separate them. But that's the warehousing and logistics part right there. But that tells you how the packaging can play into that, and the packaging can impact the inventory usage and the even the quality of the parts, or even just what's used first. But again, that goes with the same thing too. Let's say that this was we'll say this is an expendable pack. They bring the new returnable pack, put it on top of the expendable pack. This might be heavier, even though it's the same parts. This may be much heavier. This would be much heavier because it's plastic, and this may be lighter. This may not be able to handle the weight of that expendable. So I'm just giving you many scenarios that you might see, but you want to make sure that all of the old product is depleted. You want to use the older packaging. If you're getting rid of expendable packaging and going to returnable, you want to use up all the expendable first. So there's just a lot of things you have to do, and just how you manage that is pretty important. So yeah, theoretically, expendable packaging shipments and the returnable container shipments begin over the course of a few shipments. So it could switch over pretty fast. So you could go from one truck and then, today we're gonna, switch over. But that means that you need to make sure everything's depleted from an expendable version, expendable version of the pack has been moved out of your plant, and the material has been used up that went in that. Okay, so here's a case study. Okay, It's a beautiful, beautiful pack here. So this is going to show you like how to do a cash flow analysis. So this is regarding trim parts. They use the packaging show below, double wall corrugated box with the top cap. And then this box, they strapped to a wood pallet. So 20 parts for each one. Okay, so this box pallet combination is 23 inches tall, which you can see here. You know, this trailer is, you know, just over 100 inches, but this is 23, they only have 3 high. That means they've got like a lot of space here, but you can see they've stacked the 3 high and it looks like you might have some failure of this bottom one. So this says, you know, the supplier should have been able to stack them 4 high, because again, it's 23 inches tall. You got that trailer that's just over 100 inches, so you could get 4 in there. So if you take the 106 inches for the height of the trailer and then divide it by 23, you're going to get 92 inches. And they did the opposite. So let's say they took the 92, they took 4 times the 23. So they know they can go 4 high. And this is where that modularity comes in, where you know how many you can stack high. They have these heights that are set, or these dimensions, length and width that are set. So they know that they can go 4 high because they know 25 inches to get to 100 or so. So again, this says that usable height is 106, right? But I mentioned here, if they stack more than 2 high, you're going to get some damage here if this bottom box is failing. This one, some of the issues that you see here would be damage and spillage. So parts are, falling out, they're losing parts. So let's say you started off with, 800 parts in this box. By the time it gets here, these two on top crush the box and it opens up, and maybe 100 of those 800 parts have fallen out by the time it gets to its destination. So what happens is the supplier, to resolve that, versus beefing up the box, because they probably just couldn't, because this was a double wall box. So it was pretty beefy already. So that would tell me, these trim parts are fairly substantially heavy. So their option could be to beef up the box, but they opted not to do. They opted to just ship it too high. So now you've got over 50 inches of air over here. So now you're shipping for every load where you're supposed to be shipping 4 high, now you're only shipping 2 high. So if you were to ship a whole trailer load of these, we're back to that scenario where you're shipping only half. So you're actually doubling the number of trailers. So if you planned on, this is 23 inches high, I can ship 4 high, but they start crushing, you try 3 high, didn't work, so now you're shipping 2 high. Now you're literally shipping twice as many truckloads of these parts than what you planned. So those are some of the things that you look at. So to complicate matters further, some of the combinations are stacked on plastic bins. So some of the, like you see it here, this box is on top of the plastic bin. But because they were up high and they were on a pack that really wasn't made to be stackable on top with a pallet like this, then they move more. So you're seeing damage and rubbing of the trim parts. So again, stacking the containers, stacking the pallets that don't match or aren't made to nest, or they're not modular, can cause potential for damage. So again, this is what I said about here. Now, for them to ship too high, it was a major issue, because now they're spending more money for more trucks, and we know how transportation is right now. Transportation costs, fuel costs, and that's a situation that you want to avoid. So you can see for this company, they're spending a lot of money on unnecessarily money on transportation because they're sending half empty trailers or trailers that are 3/4 full. So this is one of the things that made them think, well, one of their options would be a beefier container, right? They have a double wall container here, so it's probably not going to be worth their money to go triple wall, or maybe hard for them to find triple wall. Maybe triple wall won't help, depending on what's in here, depending on that design. So another option could be, what else can we do that would be beefier? So they're looking at, switching to returnable containers, because probably what really drove this many times, and just people would live with it, but the OEM was not happy because they're opening the trailers and they have parts spilled on the floor. The parts are rolling around during transportation now, they're damaged, they're scratched, they're dirty, they can't use them. So they order 1,000, but they say they order 800, I'm gonna say, because we used that before. They order 800, but now they can only use maybe 700. So that's increased their cost per part, because somebody's got to pay for that. And let's say they're using 800 of these a day. Now maybe they're just putting one line side and they're running out before the end of the day because those boxes aren't full. And there's just so many issues that can come with that. So the OEM was not happy because, like I said, they're receiving it, they're rolling all over the floor, they have issues, they don't have what they need. It's slowing their line down. They've got to change their delivery routes, because instead of delivering 800, now they have to plan on delivering, like, for every 700 that gets used, now they've got to come back and replenish it, right? So there's just a lot of issues that they saw. So the OEM said, we're not going to take this in this package anymore. They could lose the business. So that was a big catalyst and a driver for this company to switch over to returnables. So you can see here some basic dimensions of the box. It's an AC flute. So it's 42, 26, 36, 33, 26, 42 flute, right? And then it is 18 inches tall. That pallet is standard 5-inch pallet, and it's 48 by 45. So this box itself is 48 inches length, 45 inches width, and then 18 inches height. When you look at this box, that's the 23, you're going to get 18 inches from here to here, plus 5 inches for the pallet. So that is what you see. So this is 18 inches plus 5 for the pallet. And you can see what they actually are receiving in doesn't look as neat and tidy as this proposed drawing, right? So another thing you have to look at for this particular box is expendable pack. The price was contracted between the box and pallet manufacturers and the OEM. So even though the supplier is getting these boxes in, the OEM is saying, yeah, we're not going to pay more than $20 for these. They actually, because they have many times they have more leverage because their volumes are bigger. So maybe they're using this box for other items. So because you see this right here, this box, and you see there's compression, maybe this OEM is receiving other parts in the same box. So they're able to say, okay, well, this supplier is only using 500 boxes, but in general, all of our suppliers are using 10,000 of these boxes, so they can get a much better price for it. But again, they're seeing damage. So the OEM, who is negotiating these prices, and they know what the cost of this box and pallet is, and they've contracted it, they still are saying it's still not acceptable. We want a returnable pack, something else. So that's something else, though, that I'm gonna side note. You also want to understand the pricing of the packaging. So for a couple of reasons, when you're doing the ROI, when you're doing the business case to justify returnable packaging versus expendable packaging. But you also want to know it in general, because as these launches are happening, packaging is used as a profit center. So sometimes they will add extra pricing. So let's just say this box is $10, but the supplier might actually say that this box was $20. So they are using that to make extra money sometimes, not all the time, but it's just something to be aware of. I've seen it happen where they added a nice padded margin onto the cost of the packaging to supplement the profit, because automotive is also known for not allowing their suppliers to make any money or have a margin. And I can tell you that now, after the pandemic, one of the effects has been that, the medical market has grown. Automotive is, I would say a lot of the growth is coming from used cars right now. And because of the chip shortage, plants aren't making vehicles at the volume that they were, because they have a chip shortage. So some of the parts don't use as much packaging because they're not shipping as many of those. But what they're finding is that there's certain packs that automotive used to get fairly easily, and they're having trouble getting them now because companies are saying, we're not going to bid on that. We can't make enough money from it. And the profit margin in medical packaging right now is much higher. So they would rather do medical products packaging versus automotive packaging. So that's something else to be aware of. Okay, so this is a picture of the blank for the box and for the cover for that lid. Pretty standard. Okay, you can see the measurements. It's 48 by 45 plus 18, which is the height of that box. And then you have the lid, that again is a 45 by 48. It's 3 inches, but it overlaps. So it doesn't add to the height of the box. So when you look at the material, you're going to take the 48 plus 18 plus 18 to get 84. So you got the 48. Okay, so you got 48 plus 18 plus 18, and that's going to give you that dimension. So when you're looking at the blank, you've got 18 plus 48 plus 18. And then for the other dimensions, that's the length. For the width, you've got the 18 right here plus 45 plus 18 again. So you've got the 84, which is this, and the 81, which is this. And then you get also for the cover, it's 54 by 51. So you've got 3 inches here. So you've got 48 plus, 48 plus 3 plus another 3. So basically 48 plus 6 to get 54. So this is 54. And then for the width, you're going to get the 45 plus 3 plus 3. So you get 3 plus 45, which is 48, plus another 3 is 51. So you'll take the areas of both of those and add them together. And that's going to tell you how much material you're using per box. So you're going to take that 84 times 81 for the box, and then you're going to add the 54 times 51. So you're basically going to take the area of the box plus the area of the cover to see how much square footage you're using per box. So when you do that, the 84 by 81 plus the 54 by 51, you get 9,558 square inches. And when you convert that to feet square footage, you're going to come up with the 66.4. So let me get my little calculator out. What did I do with it? Okay. No, we'll just do this. Okay, so we're going to take the 9,558 divided by 144. Okay, so we get to 66.375. So how did I do that? So again, you're going to take the 84 times 81 plus the 54 by 51 to get the 9,558 inches squared. To get to convert from the inches squared to the feet squared, you're going to divide that by 144. Okay. And that's going to give you the 66.4. So the 144 is basically square footage of a 1 foot. It's going to be 12 inches times 12 inches or square, 12 inches squared to get 144 inches. Or sorry, to get the inches, and then you use that divided by 144 to get your square feet. Okay, so you have the price of your square footage for the board is determined by the weight of the pulp and the cost to put it together. Okay, so this is a general rule. However, in the end, it gives you a good estimate, but you need to also know what your supplier is charging, because they'll add in different things that aren't really determined by the cost of the material and the cost to put it together, like services, like counting boxes for you, those sorts of things. Okay, so you can see this would be if you cut a square out, that's a square foot here. If you were to cut it out of this box or out of here, the same thing as taking a square foot of that out, then that's what this is. So you can see the A flute and the C flute and that board combination that we talked about, which we have the layers of board, and then you have the corrugated layers in between for the different flutes. Okay. Okay, and this is showing you how to calculate the sheets. You have the 3 flat ones, your face sheets. And then when you stretch them flat for the A flute and the C flute, you have your take up factor times 1, and the 1 is for that 1 foot of material, right? So you can take this take up factor, multiply it by your area, and that tells you how your length, and that's going to tell you how much further this is going to stretch out. So for example, your A flute, when it's in the corrugated form, it might be, it's going to look like it's the square inch right here, right? Into the square foot, I'm sorry, it's 12 inches. But you multiply that 1 foot on length here by 1.54. Because what that basically means is if you flatten out this corrugated layer, if you flatten out that 1 foot of corrugated layer, you're going to end up with about 1.5 feet, 1.54 of material. So it's going to increase by a little bit over 50%. This is going to increase by about 30%, and 32%. This is increased by 43%. depending on the size of the flute. So that's how you can measure that. Okay, so we knew the two outer faces for the paper weighed 42 pounds. So right here at 42 pounds per 1,000 square feet. So the reason why you know it's these two outer ones is when you go back up here, you got the 42 here and the 42 here. Okay, so you got the 42, 42, and then this tells you each one, right? So as you go through that, that's what they're going through. They're just talking about the different layers and what they weigh. So we calculated the length of the material. We've calculated we know what the weight of the material is. And so the weight for the 1 foot of board, this is how you would calculate it. You take the 42, which is the two outer layers, right? The top and the bottom. And you will divide it by 1,000 because you know that it's 42 pounds per, anywhere you see that per, you divide it by the 1,000 square feet, right? And then you multiply it by the 1 by the 1, because take-up factor for that is 1, right? It doesn't stretch out anymore. So it's just 1 by 1. That's what the measure for that square is. Okay, so those are the outer layers, right? And you'll see that here. And then you're going to also see it at the end. So I'll get back to that, but you see it twice because you know that you've got 42 here, 42 here on the top and the bottom. Next, you're going to have, the next one is 26. So you've got the 26 per 1,000 square feet. And then you're going to multiply this by the take-up factor of the A flute times 1, because that 1 is the length, and then you have the take-up factor. And then the third one is your 33-pound medium divided by 1,000 pounds per square foot times the 1 times 1. And then your next one, because that is your middle liner, right? So that doesn't have any take-up factor. That's just 1. And then the next one is going to be a fluted one, which is going to be the 26-pound liner or corrugated divided by 1,000 times 1.43 times 1, because you know that that's the C flute. So again, when we look at this, we go back here, it's a C flute. So that's how you know it's the liner, A flute, liner, C flute, liner. So that's what they're doing there. So you're going to take all this, multiply it, first divide this to get your pounds per 42 pounds per 1,000 square feet, right? And then you're going to multiply it by the length of that layer times the take-up factor. If it's a liner, it's just 1. If it is a corrugated layer, then you have your take-up factor according to this table. And then once you divide, multiply, divide, multiply, divide, multiply, divide, multiply, and then you'll add those all together. You're going to get the 0.194 pounds. So the weight of your box is going to be 66.4 times 0.194. Okay, so the 0.194 is what you get when you've added all this together. And then remember again, your 66.4 came in here. When you're going to measure, that was your square footage of everything. All you did down here was measure for 1 square foot. So you measure for 1 square foot and you get 0.194 pounds. So the weight of this cutout is the 0.194, But then in order to figure out the whole box, you're going to multiply that 1 square foot by the 66.4, and that's going to give you 12.9 pounds. Okay, so this is an old sheet. They don't use this anymore, but I think it's still relevant because you can see now a lot of the box companies and board suppliers, they don't really let you see this. You would have to subscribe or maybe know someone that works in this industry to get an estimate on the pricing. But even I spoke with someone recently, someone was trying to calculate the price of a box and just like this, and they were having trouble getting it because, the company had vendor managed inventory. So they had services they were adding on and they didn't know what the price was. So I talked to someone that works in the corrugated board market, and he keeps a spreadsheet and he just tracks it over time. And he could see certain time periods, like say during the pandemic, the volume of boxes went up, so the demand went up, so the price of the board went up. So he was able to track that, and he could say over time the average is this, but during this period it went up this much. So he's able to kind of figure it out. But before, you could actually subscribe to the yellow sheet, and you could see what current prices were for a particular time period. So this shows you here, this is like a craft liner board. You get some upcharges depending on for the different materials. This is 42 pound. But then this is like a semi-chemical medium. So depending on the process of how it's made, this can affect the price. So, but now if you want that information, you either have to subscribe to get a report that's much more expensive versus a, weekly or however often this came out. Okay, so they did it on Tuesdays, right? So they did it weekly. But now it's the whole process is different. If you go to this website, you're gonna basically go to a website that says what you like to buy or reports. Okay, so the cost of the paper for this box, they're saying, the weight again, remember this weight, the total weight was 12.9 pounds. So 12.9, you're going to take that 66.4, which was the amount of board used, right? Times that factor for your weight. So that's where that 12.9 pounds comes in. Okay. So now they're taking the 12.9 pounds, multiplying it by $550, and then divide it by 2,000 pounds. Because you can see here, this $550, you see that across here for all 3 of these. So we're going to assume they're not doing it out west, but that was the price. It was $550. They just picked that one as an average price. And this is an average price, and they're using it based on tonnage. So price ranges are listed for a short ton. So 2,000 pounds is a ton. So that's where you get that 2,000 pounds from. So that's how they estimated that the cost of the paper to make the box is $3.55. Because again, this is listing types of board, liner boards, and the mediums. So this is just listing the price of the material. This isn't talking about like how to when you're gluing these together, or all the forming equipment that you run, the labor, any of that stuff, it's not included. So what this is, the general rule of thumb is that whatever the material price is, you're going to double that to get the price of the box. So based on this estimate, your cost of your box is going to be about $7.10. So this box here, they're saying at this time it was $7.10 based on the information that they had. The volumes that the OEM was buying, that box was $7.10. So remember that your cost for your expendable pack was $7.10. Now, another thing to keep in mind, it's really good to be able to know how to do these calculations. You want to double check that with the purchasing team, if you can, if they have it, then you can do that just as a double check, just to make sure there aren't any other factors that you don't see, or maybe there's been some, increase recently that you're not capturing that maybe only purchasing knows about. So, you always want to like bounce that off of purchasing and say, hey, I calculated this to be $7.10 for this box. What are you showing in the system? Okay, and then, the cost of the pallet depends on the wood used. And the pallet is, the supplier is probably about $15. That's probably about right. And then, put in strapping, put in a little bit over $1 for the strapping. So you're looking at all the material for this box. So again, you've got the pallet, the box, the lid, and the strap. So that's how you're estimating, because what you want to do is you want to figure out how much does this pack cost currently as an expendable pack. And then you need to compare it to your returnable proposed pack. So now $7.10, that's your magic number for expendable. Okay, so now you've added in the $15 for the pallet, and then you're adding $1.10 for the strapping. So that's where you get that $7.10 plus 15 plus $1.10. So now you're up to $23.20 for your pack. Okay. So now there's also a charge that they're looking at. You want to take these, once these boxes are empty and the pallets are empty, they might be shipping them. Okay, so the total cost is going to be, it's about 25% of the cost of the part. So here, notice it says the piece cost. So purchasing has put together, as I mentioned, probably last week or week before, that purchasing looks a lot at the piece price. So they want to know how much the packaging cost spread out. So you have this part in this bin. Let's say you have 20 parts in this bin. The cost of this bin, a solar bin, let's say the bin is $20 or your tote's $20, and you have 20 parts in here, you're going to take, $20, 20 parts. So you know that each part is this part that the part basically is taking is going to cost about $1 for each part for packaging, is what they figured. And then, like I said, you got this charge to ship your empty boxes and pallets to the supplier. So that's counted in there. So the trucking costs. So when you're buying packaging, they will include the transportation cost to get that packaging to you, because they're not going to eat, the supplier's not going to eat that cost. The supplier is going to tell you, well, it's just kind of like when you order something, they charge you for shipping, right? Or you get free shipping. Well, they say it's free, but that cost is going to get rolled up. The price of shipping is going to get, cost of shipping is going to get rolled into the price of whatever you bought. So with them, they break it out because they want to know every single cost for every factor, because they want to be able to say, what if we changed how often we ship it? Or what if we do this? What will happen? So they want to be able to know every single item and be able to manage and control those if they need to. Okay, so now we've gone back to this, the exercise we did, we're figuring out how many boxes or pallets can fit in a standard 53-foot trailer. So again, So they figure out, they put, they can get 14 deep from front to back, excuse me, and then they can get 2 across and 2 high. So now you're looking at the 2 high, because with those boxes, we know that if they go more than 2 high, they will compress. So they've got 2 times 48, because you got 14. Oh, so that's a 96 inches, I'm sorry. So you know that 96 inches across, and you got 98 and a half. So they fit in here with just a little bit of room to spare. And then you get 14 front to back. So they're using that short dimension, the 45 inch dimension. So that's where you get the 14 here times 45 inches, because that's the 45-inch dimension of the box. And that equals 630. So it fits in there. And then they realize that they have 60 inches of unused space on the top. So again, these pallets are 23 inches. If they put 2 more in there, they would still have, plenty, they could fit, and they still have plenty of, they would not have to, leave any out, but they know because of the compression, they're limited to 2. So they've got 60 inches of unused space on the top because they can't load any higher. 20 parts per box. So we know that we've got 20 parts per box times 56 boxes on a trailer. And that tells you that there are 1,120 parts on a trailer. Okay. And you can see those dimensions there. It was the 48 here, the 45 here, and then 23 high. And we did that in the homework last week. Okay, so for the returnable pack, now you're ready to start looking at doing your returnable pack. And how are you going to justify that? Which one are you going to use? So you go through that whole selection process where you have your criteria that we went through before. So you're going to do all that to figure out, what container do you want to use. You already know you're using a bulk bin that is corrugated. So even though, the design criteria will drive your decision tree, will drive you towards, can you use a handheld tote first? Well, you already know that they're already using a bulk bin. So most likely you're probably going to use a bulk bin, but you still need to go through the exercise just to make sure, because maybe something changed. We have a bulk bin, maybe, or a handheld tote, maybe something fits better. So you want to go through that exercise. But assuming that they went through the exercise, they've made a decision to replace that box, that 48 by 45 by 23 inch box is going to be replaced with the 45 by 48 by 34 inch roll pack bin. Okay, so we went from 45, 48, 23 to a 34 inch bin. So we've already going with the bigger bin. Okay, so it has that same standard footprint that this is here, but it's 34 inches tall. And then remember, it collapses to 13 inches. And this is what we looked at like on those tables last week, right? So you can see from either the Orbis catalogs or the RollPack catalog or the tables from the reading that the collapsible height is 13 inches. Okay, so this bin, they use it for a couple reasons. They have the same footprint, which is great, because when they bring these in, they're not going to have to change the storage the space on the floor or in the warehouse. So if they just bring this bin in and put it right near the operators on the line, they don't have to adjust the area, the size. they don't have to say, okay, now this is going on a small rack and it wasn't a bin. So now they have to take that bin space and racks, or they have to, or vice versa. So they can just take that same footprint, put it where it was, and it makes it much easier. And then again, like I said, it collapses to 13 inches. So it goes from 34 inches to 13 inches. So, it's quite a difference. Okay, so I mentioned before, it was good because it can be stacked 3 high. So you're going to take the 106 inches, which is the height of the trailer, right? And you get 3 high, and you're going to take 3 times 34, which is the 34-inch height, right? So you're going to take 3 times 34, and then you're going to subtract that from 106, and you're going to get 4. So that tells you you're only going to have 4 inches left at the top. So that's what they did. They took the 106, which is the height of the trailer, and then they took the 34 inches here times 3, and then they just subtracted it. So let me do this again. So we've got 34 times 3 is 102. So that's this 34 times 3 is 102. So you get 106 inches here minus 102 inches, which would be this plus this plus this. You get 4 inches. So, you've almost filled out this trailer completely. It fits very, very well. And then you still have 4 inches of clearance, which is not a lot, but it's enough for the fork truck driver. So you have to worry about damage or anything like that. Good drivers don't have an issue with that at all. So, and you can go 3 high, the compression strength is higher. So that's how they know, based on the weight of the product and the specs of that bin, which went through that whole design criteria we went through last week. That's how they selected that container. So they know they can stack 3 high already based on the weight of the parts and the weight capacity of the bins. They already know that. So also, that you can go 2 wide and 14 deep, just like this one. Sorry, 14 deep and 2 wide. So it's the same. The only difference is now that you went from 23 inches and you have a constraint of stacking 2 high because of compression. Now you don't have to constrain. So you can see how many more parts you're going to get in here. So, so you're going to have the 3 by 2 by 14. So you got the 3 by 2 by 14, and you get 84 versus 56 of these. So you're getting more of these in here, and they're bigger. So this is how you know they're bigger. Besides the fact that you're going from 23 inches to 34 inches, the 23-inch one held 20 parts. Go back up here. At 20 parts per box, right? So this only held 20 parts because it's like 9 inches shorter. Now that you've got the taller bin of 34, you can now put 30 trim parts in here. So the that they use their CAD data, and they used calculations to figure out how many parts they could get to maximize how many they could. And then this says here, it was later verified using actual parts once they became available. That's key. So that would be a fit check. So, we showed last week all the calculations that they could do. They have these the software they could use to come up with how many parts and how many bins and how many things fit on a trailer and on a pallet in a box. You can do all those things, right? But you still have to do a fit check. So you have to verify the fit check with actual parts. And you want to do it with more than one part. You don't just want to put one part in there and say, oh, okay, yeah, I think I fit 20. You want to fit, or I can fit 30. You want to have as many parts as possible in this, as close to, if you can't get 30, you want to have as close to 30 as you could possibly get. Ideally, getting 30 is the best way. So basically, since you now have 30 parts per bin, because it was calculated as an estimate and then it was verified using real parts, now you know you can get 30 parts per bin times 84 bins, because you're getting 84 bins in this trailer now, and now you get 2,520 parts. Okay, with a smaller box where you can only stack 2 high because of the compression strength, you can only get 1,120. So you have more than doubled how many you can get into the trailer. Because if they were able to stack 4 high with that box, they would have just been able to double it, right? With 20 parts and you just double it. But now that you're able to get 30 parts per bin, even though you're only stacking 3 high instead of 4, you're still able to get significantly more into that trailer. So, okay, so the cost of the RoPac bin itself was $150. So keep that in mind. So we did the cost of the corrugated box up here, and we came up to $7.10. So remember that the corrugated box and pallet and strapping and everything together comes out to $23.20, right? So now we're remembering those prices. We got the $23.23 is the cost of the existing return expendable pack, this smaller, this 23-inch box. Now we know that the RoPac bin cost $150. Okay, so that seems like a huge difference. So, you're paying $23 and some change for this corrugated box that's expendable, you're going to throw away. But this RoPac bin, man, it's $150. It's so much more. So how do you justify that? How in the world do you justify that? Okay, so you want to do a cost comparison. So, so when you make it a car, you're looking at things like the transport of parts, labor and materials. Those are really the main things, just for the cost of the parts. And the cost of the parts and labor are the same. That doesn't change. Whether it's returnable or expendable packaging. So you can assume that it's going to be about the same, because your piece price is the same. So you're going to assume that the piece price doesn't change. So when you do your cost comparison, you probably can just take that out and look at just the cost of what it costs to transport the packaging once it's made and you're using it back and forth, as well as the cost of the packaging itself. Okay, so this is where we talk about the long-term cost. That's really what this cost justification, when you're doing your business case and your ROI, this is where it really comes in handy, and you can see the difference of what you're spending over a period of time. So, okay, a typical assembly plant receives 400 truckloads of material every day. So we talked about that already. We just assume they get 400 trucks. Okay, so the new model build is going to be 1 year, and that's going to be 250 days. So you're going to take out vacation, you're going to take out holidays, you're going to take out plant shutdowns when they're doing things like inventory, or maybe they have to retool the plant and get it ready for the new model. So at any given time, you're going to only be running about 250 days per year of production out of the 365. Also, if they're not running on weekends, that is a big chunk, because you've got 52 weeks and you've got so you've got just over 100 days that you're taking out of so you 365 days a year, take out 104, would you say 105, right? So now you're at you know, 260 something days a year, right? Now you take out holidays and any other breaks. So you can easily say that you are doing about 250 days of production, without weekends, with all the other things you take out. Um, so because of that, now with those 400 trucks a day that you're doing times 250 working days, you're now going to be shipping 100,000 trucks every single year. Okay. So this is a number for 2005. Um, the auto manufacturer spent about $1 billion on transportation alone, and this was 2005. So this is well before the pandemic and transportation costs went up. This was well before the shortage of drivers, because the shortage of drivers started probably around where it started significantly increasing costs, probably around 2016 or so. So, you know, that was back then. So we can imagine, we could just say they're probably doubling. I'm just throwing that number out. I'm just making up a number. They could easily be spending $2 billion a year. And this is going to be GM, Ford, and Chrysler, which is now Stellantis, right? That's not including Toyota, Honda, BMW, anybody else, Mercedes. It's not including any of those, right? These are just the big three, the ones that are headquartered in Detroit, or we think of being headquartered in Detroit, since Chrysler is no longer. But that's just a cost to bring the parts in to the plants. So this is the cost to bring this with the parts in it to the assembly plant. That's not including the cost to get these parts into the supplier. So that's just the big three automotive, not all the other automotive companies, not their suppliers. That's just the automotive companies that make the trucks, make the cars in those assembly plants. And then they spent 1.2 billion on outbound for sending new vehicles to dealerships. And that year they did about 2.4 million vehicles. So that kind of tells you, how much just the transportation cost alone, how much it adds up. And the reason why I'm harping on this is because with the returnables, you have an extra component of delivering the empties back. So you're sending a truck that doesn't have any parts in it, and it's very lightweight, except for the weight of the packaging that's going back. So you really have to have a good justification to say, oh, yep, it's worth buying this $150 roll pack and paying extra money for transportation to get it back. So you got to show that the cost of this container plus the transportation, handling, and everything is over time less than the cost of what you're paying for all the expendable packaging. Let's see. So this is very interesting. Again, this is why it's such a big deal, because the second largest expense of automakers is transportation. And I would say that there's probably a point during the pandemic where it might have been the largest expense incurred by the automakers. I'd have to go look that up and see, but I would not be shocked if at the peak of the supply chain issues and trucker shortages and labor shortages, that transportation became in the price of fuel. How could I forget that? That it's a very high expense. This says, the number one cost is the parts, which is something that, you want to kind of go for. You want the parts to be the most expensive thing, because that's the part, that's what's going on in the vehicle. That's the focus. I think in general, unless it's something like cosmetics, most people don't want to spend more money on the packaging than they did on the actual part or material. So since transportation is one of the largest spends for automotive, that's why I can't reiterate enough that it's so important to get as much material or as many empty containers on a trailer. So you want to have the least amount of air. So that's why this was something that could drive an OEM to say, we're going to look for another supplier. Because not only are we getting these damaged, but all this transportation costs, we're paying for that somehow. So that's very expensive. So that's why it's such a big deal. Okay, so okay, so we talked about that. It's so important. So the OEM, so if like what doesn't seem like a big deal, 10 or 15% more in a trailer, um, they can get, let's say that $917 is like the cost of shipping a trailer. Um, it's like $92 is 10 to 15% of that, right? So that can add up quite a bit for the cost of the vehicle to the customer. So I don't know if you've ever gone car shopping or heard someone talk about car shopping, and it seems like the dealership wants to, like, every nickel and every dime they're focusing on, because something like the transportation can impact the cost of the final cost of the vehicle. So you can add between about $100 to the cost of a vehicle, just for something like transportation. Okay, so you can tell we're getting near the end of my lecture because I'm losing my voice. Okay, so in most cases, when they start talking about shipping the returnables, they're looking at like what's called lanes. They want to try to utilize as many of these lanes that are going back and forth, because a lot of these are dedicated. So you have it's like a dedicated route or dedicated driver is going between supplier A to, a tier 1 to the OEM. And when they're done, when they drop off the parts, they're going to go back and pick up more parts. So you've got the same driver or group of drivers going back and forth, between shuttling back and forth, whether it's jet right across the street or whether it's a few hundred miles away. They are basically going back and forth. So they're going back with an empty trailer already. So why not, if you're going to use returnables, why not put returnables on those trailers? Because they're going to go back there anyway. So it kind of piggyback on that. So this talked about how the trucking companies or the carriers, when they do quotes, they will put in their quote, if they know the returnables are being used, they'll put in their quote a cost for returning those containers back, because there is a cost associated with that, because you can take the cost of the transportation, the cost of the driver, the time that the driver might need to do some loading or unloading. All those things go into the cost that they normally wouldn't have gone in there. So they will assign that to the returnables. Okay, this is saying you can find out, how many miles per gallon a truck gets. So look at your vehicle, your car, you probably get somewhere between 20 and 35 miles per gallon, right? If you've got a really good car, if you got a car that's an EV or hybrid or something like that, you get even more. But truck drivers, as you see, they're only getting 5 to 7 miles per gallon of gas. So imagine if your car only got 5 to 7 miles per gallon of gas, and you were driving from Michigan State back home to Kalamazoo or Detroit or Traverse City or Chicago, and the impact that would have if your car only got 5 to 7 miles per gallon versus what you're getting now. That can have an impact. And then, the diesel fuel, it's probably about if it hasn't really changed, $4 per gallon. So if you want to calculate how much your fuel costs for every mile that you drive, in a truck, you're gonna have 1 mile divided by 6 miles per gallon, which is an average of the 5 to 7 miles per gallon. And then you're gonna multiply that by the cost of the fuel, which you're just gonna use around $4 per gallon, right? So you had 1 mile divided by mile per gallon. When you do that, you're gonna cancel out the miles, and then you're gonna get 6 gallons basically divided, and then multiply it by 4 miles per gallon or $4 per gallon. So you're gonna get 0.67 miles or 67 cents per mile is what this comes out to. So you're paying 67 cents per mile for fuel, and then drivers might get 35 cents. So you add your fuel cost of 67 cents, your driver cost of 35 cents, things like insurance, maintenance, and then of course, there's gotta be a profit for the trucking company because they have other, costs maybe, or they just, they have a guide for how much profit they're gonna make. So what initially looked like 67 cents per mile just for fuel or 35 cents per mile for the driver, now you're up to $1.50. So you can have 300 miles, the driver's driving, let's say, and they're going between, the supplier plan, and then they're going to the OEM, and they come back. You're looking at 300 miles times 2, because you are taking it's a round trip. So they're going 300 in with the parts, 300 miles back with the empties. And then, or maybe it's just an empty truck, or then they say empties. Empties would be this with nothing in it. So that would be, when I say empties, that's what I'm saying, versus an empty truck. Either way, they're making 2 300-mile trips, and then you multiply that by $1.50, because that's your your cost per mile that we just talked about. So, and let me just get out the handy dandy calculator, right? So we're gonna take 2 times 300, which is the 600, times 1.5 for the $1.50, and that's $900 per truckload for the round trip. So easily they're spending, and that's like that's not counting any surcharges or changes with supply chain, but you can easily say it's $900 based on this for a round trip for the truck to go pick up parts from the supplier, drop them off at the OEM. The OEM takes the parts out, ships puts the empty container back on to the truck and ships it back for the supplier to start over. That's $900. So if they've got returnables, but if there aren't returnables, now they're taking that container, that truck with containers with parts, like those corrugated, that expendable pack, dropping it off at the supplier, and then just turning around with the empty truck and going back to the supplier. I mean, dropping off the OEM and then just going back to the supplier with an empty truck and picking up more expendables. So those are the different scenarios. I'm saying that because this is when I'm thinking in terms of, what's important when I'm doing my cost justification. I want to look at what the supply chain looks like, what those costs look like, and just, keep looking at those things. So you want to compare the returnable containers to the expendable containers, like I talked about. We want to look at the time period that program will last. How long will these containers be shipping? So for this one, it says that they're normally depreciated over 5 years, because that's what the IRS says. That's the 5 years is reasonable to use this, right? So we're gonna look at this based on the 5-year period. So just keep that in mind as well. So we're gonna say these containers are gonna be used over and over again for 5 years. And we want to compare how much does it cost for this $150 container to be used over and over again for 5 years versus buying a new expendable container every single time over the 5-year period. So let me go again. So we want to know the cost to buy these over and over again for 5 years and throw them away, or to take this and reuse it over and over again for 5 years and ship it back between. So that's what we're calculating. And when we do this, we're just looking at like the packaging and the transportation. Okay, you can look at, there are other things too. As I said, I have other calculators. I'll just kind of show you over the next couple of days so you can see the different comparisons and options, just to get an idea. But in general, this is the base way that it's done. And then people will add to it depending on their scenarios, their routing. As you see, we talked about different routing last week where you might have a loop where it's, you know, back and forth, or maybe there's some sort of like distribution center where they're cross docking, or maybe they're kitting, those sorts of things. So those are some of the things that would come into some of these different calculators. Okay, so things that you're looking at. You're looking at the cost of that expendable pack, right? I'm just gonna pull one little pallet out, expendable pack. So we know that based on like what that plant is making, they're making 20, we're gonna use 2,425 parts per day. Okay, now in this one, for this particular example, we're using 240 days. I mentioned before, when we talked earlier, for that one example, they were using 250, but for this example, we're using 240. And then the number of the parts that the supplier needs to ship over 5 years. So keep this in mind. They know they're using 240 days per year. Okay. They're using 2,425 parts per day. Okay. So this is telling you how much you're using over a year. 2,425 parts per day times 240 days in a year. That tells you how many they're using in a year. But we know for this scenario, we're calculating 5 years. So we're going to multiply that by 5. So over time, they're going to be shipping 2,910,000 parts over a 5-year period. And it doesn't matter whether you're shipping those 2,910,000 parts on here or on here, it doesn't matter. Okay. Because we're going to compare the cost for both and spread out the cost of the packaging over the parts, depending on how many we use. Okay, so we know that you have per truck, you're shipping 1,120 parts for every truck. Okay, so that means that you're going to take the number of parts that you're going to use over the 5-year period, that 2 million. Oh, wait a minute, I skipped over. Okay, so first you get 20 parts per box, and you're going to take the total number of parts used over that time period, which that we just calculated, the 2.9 million, and then you're going to divide that by 20, because that tells you how many parts per box you have. Okay, and you're going to get $145,500. I mean, 500 at a cost of $29. So that's basically the cost of your box, right? You're going to take that 145,000 parts or boxes, I'm sorry. So this is telling you have 2.9 million parts divided by 20 parts per box to give you the 145 1,500 boxes. And then you know that your box cost is $29. So you take the number of boxes times the cost, and you're going to be spending $4.2 million. $4,219. $4,219,500 boxes or expendable packs. So you're spending $4 million on expendable packaging, okay? At that same, looking at your parts per truck, now we know based on that box, we can get 1,120 parts per truck, okay? And we know that you're going to take what you're trying to do is calculate like how many trucks you're going to have. So you can calculate your cost and everything. So you know that you have the 2.9 million parts that are used over the 5-year period. You're using 1,120 parts per truckload. That tells you that you're going to be using 2,600 truckloads over the time period. Okay, so you can either do this divided by the 1,120, or you can say 145,500 parts, which is what you, or boxes, I'm sorry, divided by 56, because you get, you know, you're 145,500 boxes total over the 5-year period, and you can get 56 on a trailer. So the 56 is how many per trailer you get, and that tells you that the same thing. So that's kind of a double check that you're going to be shipping 2,600 truckloads over the 5-year period. Okay, so for this particular supplier, you see there is giving you the cost and the numbers that you use. So for this one, you're going to take the 2,600 truckloads and multiply that by $625, because you've been given the information that your cost is $625 per truckload. So earlier we calculated that other example that tells you like how much a truck cost can fluctuate. We know on this particular example that the truck cost is going to be $625 per truckload. So you're going to take that $625 per truckload, multiply it by 2,600, and that's going to give you $1,625,000. So that's your freight charge over the 5-year period. Okay, so we're looking at the cost that you're paying for your packaging of 4.2 million, your cost for freight is the 1.625 million. So you're going to take the 4.2 million plus the 1.625 million, and you're going to come up with 5,844,500. And that is the cost of the total to ship over a 5-year period. You're going to spend $5.8 million to ship the boxes and the pallets, to ship all the parts that you need for 5 years. Okay, and that's again the expendable pack. So now you know for 5 years you're going to spend $5.8 million on expendable packaging. Then also you have what else? Things like disposal, labor, interest, those sorts of things. So I'm going to stop here because it looks like we're out of time. So now you know that we've gotten to the point where we've calculated the expendable pack. We know that based on this example, if we spent $5.8 million over a 5-year period on expendable packaging that we're going to ship in. The supplier is going to send it to the OEM on expendable packaging. They're going to drop it off at the OEM. The OEM is going to use the parts and throw the packaging away. They might recycle it, they might compact it, whatever, but that packaging is going to be, that's the end of life for it. They're going to be done with it. And then the empty truck's going to go back and pick up more full pallets of expendable packaging. So we're going to end with that for today. We know that expendable packaging costs $5.8 million. So remember that. So tomorrow we're going to do a comparison of what does the returnable pack cost, right? And you can compare those two. So we're going to see 5.8 versus what for this over a 5-year period. We know this is $150. How much is it going to cost to when we buy these $150 bins? How many are we going to need? All those sorts of things. So that is pretty much it. All right. You guys have a wonderful day, and I will see you tomorrow. Bye-bye.